Assalamualaikum warahmatullahi wabarakatuh. Today, we from Group 10 we present for Set B. For introduction, firstly, AC is the name for the kind of electricity that delivered by power lines to resident and commercial building. Next part is DC. It's a single direction of flow. Furthermore, MOS multimeter can also be used to identify whether an AC or DC current present. In addition, semiconductors are used in different applications, combining the advantage of silicon and germanium or silicon-germanium. Silicon-germanium has proven to perform better than temporary silicon, while remaining compatible with current production technique, used in fast-moving part and radio frequency circuit. For methodology, we use the relevant tools to choose component circuit, create circuit diagram, and do simulation. Firstly, promote original approach to issue solution. Secondly, as they evaluate the effect of their solution on the environment, they give special attention to sustainability, looking into eco-friendly material and ethical end-of-life management. Thirdly, the researchers has created a detailed implementation plan that include cost-benefit analysis, resources needs, and feasibility concern to close the gap between theory and practice.
Okay, next move to selection and justification of the simulation component. First is transformer. Step down 250 BRMS AC to 9 BRMS, 10:1:1. Provide isolation between AC mains and DC output. Second is diode, D1 and D2. Full wave bridge recruiter converting AC to pulsation DC. Third is capacitor, C1 until C8. Filter pulsating DC from rectifier for smoother output. Value chosen based on desired ripple voltage and load current. The last one is voltage regulator, U1 and U2. LM7809CT and LM7909CT regulated DC output to positive 9 voltage and negative 9 voltage respectively.
The power supply circuit's main goal is to convert 240 volt AC with a 50 Hz frequency. It uses a ratio 10:1:1 transformer to lower the voltage, followed by rectification with 4 diodes to get pulsating DC. LM7809CT and LM7909CT regulators maintain a constant 9 volt and negative 9 volt DC output. 8 capacitors, C1 until C8, reduce voltage ripples for a stable 15 volt dual power supply. Based on figure 2 shows a voltage regulator circuit turning 240 volt AC into a consistent 9 volt output using a bridge rectifier and capacitors. The transformer reduced 240 volt to 24 volt AC converted to DC by diode. Filtering with capacitor, C1 eliminates AC ripple. Voltage regulators, U1 and additional capacitors, C2, C4 ensure a steady 9 volt output. Diode D2-D3 offer reverse voltage protection. Using a multimeter confirm a 9.55 volt and negative 9.55 volt output, verifying voltage regulation. The circuit's precision and reliability qualify it for various electronic applications requiring stability and accuracy.
Figure 3 and 4 depicts a common sinusoidal waveform in physics, characterized by a smooth, cyclical pattern with a frequency of 452.971 seconds per cycle. The wave oscillates between a peak of 272.783 volts and negative 33.178 volts, illustrating its vertical position from the center. This rhythmic motion is accurately described by the sine function. The multimeter XMM1 and XMM2 in this figure display set values of voltage and current, with voltage readings at 33.178 volts and negative 33.178 volts, and current readings at 9.595 ampere and negative 9.645 ampere.
Okay, now criteria solution. First, addressing inefficiency. First, switch linear regulator U1 and U2 with switching regulator buck boost converters. Second, it reduce heat dissipation. First, lower voltage transformer and optimize component selection. Second is boosting efficiency. Optimize capacitor use. By reduce capacitor count, select appropriate capacitor type. The last one is enhancing sustainability. First, implement energy saving features by sleep mode and auto adjust output voltage. Second, utilize green materials and processes by recycle material and energy efficient manufacturing.
Advantages of proposed solution. First, environment benefits such as eco-friendly solution often will lead to reduced environmental impact, helping conserve resources and also minimize pollution and low carbon emissions. And my second point is cost saving. Saving is a long-term cost benefits that arise for energy consumption and also efficiency to waste reduction and sustainability practice. And Market competitiveness can make consumers increasingly favor eco-friendly products and also enhancing a company market position and appeal. And my last point for advantages is regulatory compliance, like adhering to sustainability practice can make compliance with the environmental regulations, mitigating legal risks. For my disadvantage of proposed solution is a higher initial cost, because they can implementing eco-friendly solution that can make higher upfront expenses for new technologies or sustainability materials. And then limited availability, like some eco-friendly components or technology, they have a limited availability and option for certain industry or application. And then transition challenge, like shifting for conventional practice to sustainability ones may pose logical and operational challenge, requiring adjustment in the process and supply chain. And then the higher materials in the design that can lower power consumption component and recyclable through the manufacturing usage. For the eco-friendly component and sustainability assessment, first we have a resource efficiency, like innovation proposal likely has a lower environmental impact in terms of resource extraction and usage due to emphasis on eco-friendly materials and efficient designs. And then my next point is the innovative proposal, like lower environmental footprint compared to the traditional designs that are considering factors such as resource efficiency, energy consumption, waste generation, and end-of-life impact. End-of-life consideration, like first the material selection, that can use the material that are the easily workable and have the minimal environmental impact. And then prioritize materials like establish recycling process and facilities the disposal base. And then the third point is the modular design, such as design component like modular structure allowing the easy assembly. And then this is not only simplify the cycling process, but also they can enable user to replace the specific models and extending the product or the product life. And then the lastly is the labeling and aspirations, is a clearly label different material used in the component, and then they can make easier for recycles to spread and process efficiency. This can ensure that value materials can be reclaimed and more be effective.
That part is about implementation strategy. Okay, as we can see at the slide, for implementation strategy, I just state 5 points, which is regulatory compliance, supply chain integration, cross-functional collaboration, employee training and involvement, and also technical integration. Cost-benefit analysis. Okay, for cost-benefit analysis, I will compare two design, which is traditional design and innovative design. Okay, for traditional design, initial investment, it will give a lower investment because it readily use materials and construction readily. Okay, for operational cost, traditional design, we will use higher cost because we may require more energy and more materials to do the design. Okay, next we move to innovative design, which is for the investment. Innovative design need the higher investment because it incorporate the cutting edge technologies and materials. So for operational cost, it will different, like it just use lower cost for operational cost because it use the technologies readily. For conclusion, I will state by the process of collaborative thinking has resulted in a collection of creative power supply design concepts that are in line with the company's sustainable objectives. That means whatever project we do, we will also consider about sustainability objective to make we get it.